Okay, so file system stuff. You guys have been running commands, I think mostly blindly, unless you really had the gumption to kind of dig into what it is that you were doing. So I'm going to try and dispel a whole lot of the questions that you might have. And we'll go through this, I won't say slowly, but I'm trying not to go through it too terribly fast, because each of these things that we're going to cover today is, it's really important. They are very important. These tools are the tools that you're going to use every single day. Every day that you log into a Linux machine, I guarantee you, on this page, you will use at least 3 to 5. Every day, every time, all the time. So if you don't get these tools understood and under your belt, you're going to have a really hard time adminning any kind of Linux server at all. So it is extremely important that you practice these, right? I get it. I'm going to ask you to do stuff in the terminal. I'm going to ask you to do stuff through the homework, through the labs, through the quiz, whatever. That cannot be the only time that you ever use these commands. It just can't. It cannot, right? Like, I will teach you how to ride the bike, but you must practice riding the bike without me there making sure, oh, be careful, oh, watch out. Oh. You got to practice it. You have to practice it. You have to. If you don't, the pedal won't make sense. You won't know that left and then right and left and then right, right? It does not make sense until you start dealing with this stuff all of the time. And I could give you 76 labs. I could do that. But, I mean, mostly because I don't want to grade it. And if I don't grade it, then y'all will be like, well, it wasn't for a grade, so I just didn't do it. So, I mean, it's not like most of you are going to do it anyway. So the thing about this is you're really going to have to just do it. You have to 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 force yourself to do it. You don't want to do it. I did not want to do it either. But until you do it, you're not going to get it. So I'll get off my soapbox about all that. But it is important. So we're going to start off with the command cd. This is one that you're going to run into all of the time. If you're traversing the file system, right? So think of it like this. When you're in Windows, you open up a file explorer and you double click on this and you double click on that and you double click on this and you double click on that. Now you're 5 directories deep and you don't know where you are, right? I mean, this is the idea. Every time you open something, you go into a directory, you go into downloads, whatever, and you're in this spot. But a lot of times, Windows doesn't tell you exactly where you are. Hey guys, thank you. So it doesn't really tell you where you are. You've got to actually dig to figure out where you are, what you're doing, and all that kind of fun stuff. So you can do that if you're curious. You can do that in PowerShell. It'll give you kind of an idea of where you are. See users Leo downloads. You can also hit properties on this. And C users Leo plus whatever directory you're in. But that's the idea, right? Every time you double click on a folder, you go down further. This is the same way. This works the same way. So you can see what's going on. And I've got this command a little further down. But this is one that you'll probably want to commit to memory just because you're going to ask yourself a lot, where am I? PWD will help. I've got a joke about that as we hit it here in a little bit, right? No, maybe not. Ooh, I don't have it on here. So good, I get to talk about it right now. Yay! So PWD. This is a command that actually stood for print working directory. So if you remember, I think it's back in the operating systems class, and maybe at the beginning of this class, the idea is that Linux and its heritage started back in the 70s and the 80s. So a lot of the things that you're going to encounter in Linux tend to have really long lineages, and that means that someone back in the 70s or the 80s thought of what that acronym stood for. Well, it's been like 40 years. Things change. And in this case, this is one of the best examples of things changing that you can find in a Unix or Linux-based system. So PWD, print working directory. What that means is when you type this out on a teletype terminal, it would send that request to the mainframe. The mainframe was connected up to a printer, and that printer, the mainframe was connected back up to your computer, and your computer, your terminal, was connected up to a printer. So you typed in PWD, and you hit enter. That sent it to the mainframe processed it, sent it back to you, and then sent it to a printer, and then that printer screamed, literally. Y'all heard of dot matrix printer? Y'all bought a car like 10 years ago? Maybe? I mean, I don't know. Some car dealerships probably still do this. The one back in, 2012 that I worked at? Still did. I had to deal with those all of the time, and I hated those things. But, right, it was the ones that sounded like a 56K modem dialing up every time I tried to print a line. It was, right? So your terminal, your teletype terminal was connected up to a printer like that. You typed in PWD, and it literally printed your working directory. That's where that P comes from. Print. Working directory. So whatever directory you're working in, it will physically actually print it. The reason it would print it, can anybody tell me why it would print it? You didn't have a screen. What? Yeah, it just didn't exist. Monitors did not exist at that time. So a lot of times you were flying blind. There was a lot of things that you just typed and just kind of hoped for the best. Right? So PWD, that's where it came from, but it's still really useful, except we have monitors now, and it will tell you directly what it is without having to send anything to a mainframe and all the way back, right? But think about it like this. This Linux class is going to get into cloud technologies where the server that you're working on does not even exist in your state and may not even exist in your country. So you're sending these commands across vast amounts of space, right? So we've kind of made a return to 40 years ago, where the computer that you're working on is not in front of you. You just have something that is accessing that computer in front of you, and that computer is sending you back commands and results and all that kind of fun stuff. So what's old, or what's new is old, or what's old is new again, whatever. Something right? Everything comes full circle. So anyway, PWD more often than not stands for present working directory now, unless you consider printing it on the screen, printing it. Anyway, present working directory. It's really important. PWD, it will show you where you are no matter where you are in the entire system, right? You go into /etc, present working directory is etc. So it doesn't really matter. CD firewall D. Here, let me make that smaller. There we go. That way you can see it. Oh, I can't go in there because permission's denied. Like DM, how about that? Oh yeah, cool. So OpenSUSE, not all distributions of Linux will actually give you the full path in the prompt. Looks like OpenSUSE will though. So you don't actually have to use PWD all the time in OpenSUSE. It's going to give you this. After that colon, it gives you the whole working directory there. So it just keeps it fresh. So all you got to do is just reference it. All right. So CD. There are a couple of things you got to know with CD. And those are file paths. There are two different types. A absolute file path, which includes the very top of the file system, and the relative file path. So, let me explain. So this / is the very top of the file system. Here, let me do this. Can I do it here? Yeah. Custom. Crank it up a little bit. Cool. That should probably do. Does that help a little? Those of y'all reading it from 7 miles away? All right. So that is the very top of the file system. Everything in the entire system exists underneath that somewhere, somehow. So if I go to my home folder, oh, actually, if you just type cd by itself, it'll take you to your home folder. Notice that, which was the very top of the file system, changed to that. That is just an easy symbolic representation of that. So your home folder, right? Every user has a home folder matching their username, and that exists in the home directory. Reason I bring that one up is because this is where you start. Every time you open up a terminal, this is the place that you're going to start. You're going to notice that tilde. It shows up all over the place. And that's going to be your original, or at least starting, working directory. Every time you open up a terminal. Every time. So if you want to move to, let's say, the etc directory, you can't just type in cd etc. You would have to type in the absolute file path. Everything including that leading slash. So if I wanted to get there, I'd have to type in that / first. And it puts me there. So let me get a long listing of everything in that at the very top of the file system. So this is just list. We've used this one a few times before. Show me all the stuff inside of. In the long form, the root directory, or the root of the file system. So it gives me this, right? Bin, boot, dev, etc, home, lib, lib64, mount, op, proc, root, blah, 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 right? Since all of that stuff exists in the root of the file system, and my present working directory is not currently that, I would always have to write that /. Then I can go into mnt. And no matter where I am, that'll work. Doesn't matter how far, how deep into the file system you are. If you type it like that, it will always work. That's why absolute file paths are the most explicit. Because it doesn't matter where you run it. If I'm in here and I want to go into var, I can do that. If I'm in var and I want to go into run, I can do that. If I want to go into sbin, I can do that. Right? I might be, yeah. Outside of permission issues, I'll always be able to get there. So that works with everything. If I want to go into that directory, it doesn't matter what directory I'm in. If I want to go into from there, you can go there. So absolute file paths are the explicit way to get from one spot to another. Another good example would be, so I'm in the bin directory now, right? You can see that. If I wanted to go back home into the downloads directory, I can type it just like that. That is the absolute file path of my downloads folder. So the hardest part about this is kind of committing to memory how the file system is structured. I think most people can understand the absolute file path, but it's remembering exactly where the downloads folder is in the first place. That's the hard part. Not typing it, just remembering where it is. So that's absolute file path, the whole thing. Let's look at relative file path. So relative file path is basically going step by step by step by step, depending on where you are. So you don't always have to type in /home/leo/downloads to get there. So in the case of, let's say I'm in my home folder, right? pwd. So the /home/leo part is already given to me. I'm already here. So at this point, I can use a relative file path to get to downloads. And it's easier to deal with because I have to type less. So if I do a long listing, you can see I've got a bin directory, desktop, documents, downloads, music, pictures, public, templates, videos. So if I want to go to downloads, but I don't want to type in the entire absolute path to get there, how do you think I might be able to do it? Any guesses? So, if you start with a leading forward slash, that assumes that there's a directory called downloads at the very top of the file system. And we're not there. So for relative file paths, you can just get away with not doing any slash at all. CD downloads. It's just because it assumes, the slash at the end assumes that I'm going to type more. So it just sticks it out there. It doesn't affect. If I just hit enter right here, it'll work. It doesn't affect anything if I leave it there, but it also doesn't affect anything if I take it off. So if you type it just like this without that following slash, it'll work just the same. So this is a relative file path. So I don't think I have it. Yeah, I've just got a couple RPMs in there. So let me make a couple directories. Let's do test one. Yeah, that's fine. So let me go back to my home folder. And relative file pathing does work, even if you're talking about multiple directories. So let's cd downloads, and then test one. So what I just did right here, kind of just glossed over that, is create a directory called test one. Let me show you. I should have done that before I got out. So back in downloads, I do an ls, and that same stuff is there, but now there's a test one directory. There's another way to look at it. You know it's a directory because of that D right there. Also because it's blue. And if I wanted to get into it, I could just type in test one. So before I do that, look at this. Present working directory is home Leo downloads. If I cd into test one, that takes me to home Leo downloads test one. Now I can start making stuff inside of here. Doing, moving files around, copying things from one to another, deleting files, whatever I want to do. So you can do the relative file path here as well. So you know that test one exists in the downloads folder. And we're at home Leo right now. So I can cd downloads test one. And it works. Right? So I was here. I typed in go to the directory downloads test one, and it knew what I meant. Home Leo downloads test one. Right? So when you're doing relative file path, what it really means is that you're going to be adding on more directories, but those directories exist under where you already are. Right? So if I went to the root of the file system, I wouldn't be able to do that. cd downloads test one. Huh? If you do a long listing, there's no downloads directory here. There's a dev. I can go into dev. And if there's a download directory in dev, it would work. But other than that, if it doesn't exist right where you are, then relative file pathing is most likely not going to work. There's shortcuts that you can add onto relative file paths to make it work in situations like that. But once you're going to that much trouble and racking your brain to do weird kind of shortcuts to get where you want to go, then you might as well just use the absolute file path, at least that way. You won't run into any mistakes. So what I mean by that is, so like you can go to your home folder, and I want to get to Etsy. You can do weird stuff. Go up a directory, and then Etsy. That'll probably work. Yeah, it takes me to Etsy, right? But this is what I'm talking about. You have to actually think about what that means. I do not want you guys delving down that far. I didn't want to bring something up and just not tell you about what it was or show you what it looked like. But There are ways to get up and down in the directory tree by using shortcuts, and this is one of those ways. But again, if you're going to this much trouble, just type the absolute file path. That way, once you get more seasoned with dealing with Linux stuff and you want to move up a directory into a different directory, you can use shortcuts like these. But for right now, stick to the absolute file path or simple relative file paths, right? Like this directory exists inside the directory I'm already in. Let's go into that one directory. So what I mean by that is downloads is in here. CD downloads. Cool. Easy. Keep it simple. Keep it simple. All right. So we used ls. You guys kind of have an idea of what ls is. It just lists things. Just doing ls like that gives you kind of a vomity way of seeing everything. If you look at the root of the file system, it's fine. Let's go into dev. Not so fine, right? It just got chucked all the way up here, and you're kind of stuck sorting through everything. Not that it would be much easier in a formal fashion, but if you do a long listing, it'll give you a top-down list. That way you can scroll. Everything seems to be in an alphabetical order. You don't have to worry too much about where stuff is, right? If whatever you're looking for starts with an M, go to the M's. But in a form like this, you have to figure out exactly how it's doing alphabetical to figure that out. I mean, it's column from left to right. It's going alphabetical, but it just looks way too crazy for me. You might like it that way. By all means, don't let me tell you how to deal with the terminal. Everybody kind of has their own way of understanding and dealing with stuff. So if you like it better in a non-long listed kind of way, all right, cool. I'm not going to stop you. It's fine. So ls. Now there's one other thing that I want to show you. So let's look at a long listing of my home folder. Let's add another option though. So let's do the long list and A, which stands for all. What? See all that? Now, I don't know how closely you paid attention to me in the operating systems class, but we talked about this idea called app data. And app data exists in your user folder in Windows, and it contains all the configuration about all the applications that you might run. Right? I mean, your Word might be defaulted to Comic Sans at 16-point font. But let's say you go home for the day and someone else uses your workstation, they log into their account, and their Word is defaulted to Times New Roman at 12-point font, right? They are a sane human being, and you are not. But those configurations are stored in app data in your user folder. This is the same idea. This is your cache, your bash configuration, your bash history. And these will all be different depending on who you are, what user you're logging in as. .mozilla, which is the company that owns Firefox, which means this is where your Firefox configuration exists. But most people don't ever touch this stuff, right? Half the people that don't touch this stuff don't even know that it exists, right? How many people knew app data existed before you hit the operating systems class, right? And I mean, depending on how much you paid attention to, you might not know it exists now. So you're in this situation where if people don't know that it exists, and you certainly don't want people messing around with these files because you can break them, you'll hide them, right? So in Linux, how do you think you hide files? Take a look at this. One of these things is not like the other. Right? You can always see bin. You can always see music and pictures, right? Those are familiar. Ah, yes. The preceding period on any file name will hide that file in Linux. Now, it's obviously not hard to reveal those files. All it took was me typing in the A, and they're all revealed. So, obviously, you're not doing a really good job. You're just hiding it from view, right? You're putting a rug over the dirt. Sweep it under the rug, right? The dirt's still there. It's easy to find, but you have to know what you're looking for, right? You have to lift up that rug in the first place to know that there's dirt underneath, and I've been lazy. But this is a very lazy way. Turns out there's a whole story. I won't go into it, but it turns out that the dots were more of an accident than a really well thought out way to hide files. The dot is, again, a vestige from the 70s and 80s that was like, let's just do this really quickly. And then it caught on, and then it was too late to change it. And everybody was like, well, that's how hidden files exist now. So, whoops, there they are. But then everybody caught on to that and started using it. And therefore, in 2020, 45 years after this idea was constructed, we're still stuck with it. So, whoops, there it is. All right, file. So obviously, there are all these different colors in the terminal, right? There's this green thing. There's this blue stuff. In dev, you saw some weird other colors, right? Yellow. This other different kind of yellow. Right? All kinds of cool stuff. That greeny thing. So, how do you know what any of that is? Well, there's some clues over here. D, directory. C, a character. It takes input. And L, link. And then you have, if there's some in here, this dash, which means regular file. Really what that just means is text file, right? So you have clues. But sometimes you run into this thing that's a regular file, but it doesn't make any sense because it says .rpm, and you're like, what even is this? What even is an RPM? So let's look. Got a couple RPMs in here. File. Oh, wait. CD downloads. That makes sense. So file. And it tells me this file is RPM version 3 binary, works on 64-bit machines. Very revealing about what the heck this thing is. Now, I get that not all of that makes sense, but bin is always short for binary. And that is the architecture of the system that this RPM will work with. And there are tons. There is PPC, PowerPC, back in the day before 2008. Apple ran all on PowerPC. Now there's ARM and ARM64, like Raspberry Pis, lots of embedded systems, your router at home, all work on ARM64 architecture. So that would say ARM64 if it was an RPM for, obviously, ARM64. And tons of other things, right? Different types of CPU architectures you could have. And that's what exists back here on RPMs. Well, let's do file test 1. What is it? So test 1 is a directory. So if for some reason the D didn't tip you off when you're doing an LSL, you can actually ask Linux, hey, I don't know what this is. What is this? Tell me what this is. And that will typically give you some clues on how to deal with it. If it's a directory, you can go inside of it. You can see inside of it. You can do an ls on it. You can cd into it. Let's look at, I don't think I have any regular files in here. Not in there either. How about, actually, you know what? We'll look at the touch command here in a minute. But, oh, that's actually going to be a really bad example. So, right? So I've got accounts in here or something. Of course, it's an empty file. So let's do... Don't worry about that. We'll cover that later. What I'm doing is I'm getting the terminal to say text, and then instead of putting it out to the terminal itself, redirecting it into that file. So if I cat account.txt, it has that text in there now. So funky ways of text manipulation. We'll get into that a little later. But what I wanted to do was actually figure out now. Account.txt is a. So ASCII, yeah. It's pronounced ASCII. Don't another one of those 80s vestiges. Blah blah blah. It's just basic text. So you can think of ASCII as basic. ASCII text. So it's a text file, right? So what if we go into Dev and start asking questions about files in here? How about file 0? Character special. So it takes character input. How about TTY? Let's do 0. Well, let's do 1. Character special. So 0 and TTY1 all accept characters. Look, this one looked a little different. The yellow is a little darker, and it's not bold, and it's got a different thingy. What is that? It's a named pipe. So what that means is it can take redirected input. We'll get into more of that as well. Let's see what else. What else is in here? Let's look at. Let's look at log. How about file log? So it tells you log is a symbolic link to run systemd journal dev -log. So log is a shortcut. Symbolic link is another word for shortcut. So, and it points to this. So when you type in log, you're really meaning this. This is really where it's pointing you to instead. And then I wanted to look at just SDA or whatever. Let's see. Let me see if it's even there. Yep. Okay. So let's do file SDA. Yeah, SDA. Block special. So it's a block device. If you look at PC hardware, you realize that every little thing that a hard drive is going to record is recorded on blocks, and then sectors, and then partitions, and then as you work your way up, right? But block is the smallest form of data. And a block might be, a megabyte. So if you have a 1 kilobyte text file and you write it into a block, too bad, you lose the rest of that megabyte, right? So anyhow, block means it's a block device, meaning it can hold stuff. It can remember things. It is a disk of some sort. Then if we do file SDA1, still block special, but SDA1 is a partition. Anyhow, that's the idea. You can feed anything into file and then get some information about what it is that you're looking at. So let's look at file SRO. Yeah, it's their CD-ROM drive. So this is a symbolic link to this, which is a block device, a storage device of some kind. So anyway, file, super important. You're gonna run into it a lot. Touch, I already showed you how to do that. Let's go back to the home folder real quick. That's how I created the account.txt. To be honest with you, that's not really what touch is for. If you tell Linux to deal with something in a file that doesn't exist, Linux just assumes that you want that file there. So it's gonna make it. So touch is not actually for creating anything. It's meant to update this. So if you've got a file that has a lot of logs in it and you want to know the last time that log was looked at. Think of it, you ever go into the bathroom and see that log where it's like last time this bathroom was cleaned, should have been 6 hours ago and someone didn't sign it, and you're like, the bathroom's extra dirty, right? Yeah. That's what this is. That's what touch is meant to do. Update that date and time so that you know exactly when the last time this thing was messed with was, right? So if we touch account.txt, the time gets updated. It was created or last touched February 4th, 1134. Touched it again. Last time it was touched February 4, 1139. It's only been 5 minutes, guys, since I made that file. Feels like an eternity, I know. So anyhow, that's what it's for. But let's say that you misspell it. Oh God, now there's a whole nother one, right? He said he wanted me to touch the file, so I touched the file, but it didn't exist, so now it exists, and I touched it, right? Linux is gonna do exactly what you tell it to do. You told it to touch it, didn't exist. It touched it, so it has to exist. So another command, rm acnt.txt. I won't tell you what it is, but we'll do that, and then we'll do another long listing. What did it do? Remove, right? Some of these are better in show than tell, right? That's exactly what remove does. Deletes it. Now, here's the thing. There's no such thing as a trash can in the terminal. Whoops! So, when you remove it, it's gone. It's gone. Like, there's no special place that it goes until you decide that you want to do, empty-trash.bin or whatever. Like, it's gone. It's gone. You can create aliases or shortcuts to save yourself that heartache. You can say, instead of actually removing it, you can put it into a directory inside of temp and then delete temp every 30 minutes or 30 days or something like that, right? You can always do that. But yeah, no, I mean, you told it to remove it. Linux took you at your word, so it removed it. So unless you're doing some kind of special magic or the distro that you're using does some special magic, it's gone. Gone. So, oh yeah, cool, so copy. So let's say that account.txt gets updated once a day, and we want to keep backups of this thing. And we want to do that once a week. So we can set up cron to do this for us every week. That way we know exactly when it's running. We can look at the log and we know that it works and yada, yada, yada. Well, we're not cool enough to use cron yet. So we're going to manually do this. Every Monday morning, we're going to come in and we're going to manually copy this file. And it's going to be horrible because you have to manually do it. How do you do that? Well, CP. Now, the way that CP works is it needs a source file and a destination file. Think of CP as a copy from where to where. Everything works out in English if you try hard enough. And CP is no different. From where to where. Right? I mean, just imagine if you were telling someone how to copy a thing, right? Copy this 17 times. Or copy this onto parchment, right? But you got to give them something to copy before you tell them where to copy it to, right? Otherwise, there's all kinds of confusion. I don't know what to copy and I don't know what's going on. So tell it what to copy first and then where to copy it. So copy account.txt. And I don't want to do anything special with it. I just want to have right here in the same directory and everything. I'm going to copy it inside of here. So account dot, let's just call it backup. Now here's the age-old question. Did it work? How do you know that it worked? It didn't scream at you. Yep, seriously. That's how you know that it worked. I'm pretty sure there's got to be a V on here or something, right? Yeah, it's a V. So we can do it again if you want. Let's call this backup 2. Let's add a V option to it. Okay, cool. So if you want, if it really is a source of frustration for you that Linux doesn't tell you anything when it actually works, always add the V option. There's pretty much every command has a V option. It'll tell you exactly what happened. So let's look. So I've copied 2 files, or I've copied the same file twice. And you can see, this was the earlier one at 1143, account.backup. Then the one I did next was account.backup.to. With or without the V option, it did exactly the same thing. Not a whole lot going on there. It literally just copies it. That's it. Now, what if I want to move one of these files? Copy is great and all, but let's say that I copy it here for temporary holding, and then I want to move it to, I don't know, wherever I need to move it to, wherever that might be. What are my permissions on this? Nope. I can put it in temp. That'll work. All right, so I can put it in temp. So here's what I'm dealing with, one of these two files. I want to move backup.to to the temp directory, TMP, right here, this one. So I need you guys to help me with the absolute file path on that. Temp exists in the root of the file system. That's where temp is. I am here at home Leo. I'm going to move this file to there. So, I'll give you this part. Move. Move works just like copy. Got to tell it what you want it to move, and then where you want it to move to. So, what do I want to move? Account.backup2. All right. Where do I want to move it to? Temp is in the root of the file system. /temp. Yep, just /temp. So that is root. And then if we do that, I assume it worked. Let's go to TMP and let's list. If it worked, the file will be here. If it did not work, the file will not. Oh, there it is. Account.backup2. So it is there. And that's the whole point. But I want you guys to pay attention to something. We used both, a relative and an absolute file path, right? Because I was in the home directory, so we just called account.backup2 by name. Cool, it's in here, that's fine. Linux knows what that means. And then we told it, all right, move it in the root of the file system, there's a directory called temp, move it in there. So move, relative file path, absolute file path. All right. DD. DD is another way to copy, but it's, what's the word I'm looking for? It copies block devices. Ooh, I don't know why that escaped me. That is really what it does. It copies block devices. So, if you want a copy of an entire hard disk, the whole thing, like partitions included, right? Every single nook and cranny of that disk, you want to use DD. There are better ways, but DD is pretty important. It is the easiest way to take a backup and then plop it onto a totally separate but identical disk. And if you ever wonder, if you ever run into a situation where that first disk dies and you need to be able to just slide in a new disk, DD is going to help you do that. So, DD is like copy, but way more intrusive. All right. And so the idea, or the way that you put it together, is still the same. It's just the syntax is a little different. So DD doesn't actually have a definition. They wanted to call it copy and convert. Its real name is copy and convert, but CC was already taken. So what did they do? Like the guys back in the 70s do, they just incremented the letter by 1 and called it DD. Yay! And over time, it has gotten a reputation for blowing things up. The reason for that is because DD don't care. You told it to do what you told it to do. And it's going to do what you told it to do. And if that means copy one disk to another disk, but you got them backwards and it was actually all the disk with the files or what you copied on top of, well, DD did it because you told it to do it. So now all your files are gone. So you got to be careful with stuff like that. So input file, output file. But the idea is the same. I want to copy this to this. So let's say I had an image. Oops. So I've got this thing, raspi.image. I can use DD to talk about it. Raspi.image, output file of dev SDA. Well, you can just say dev SDA. So remember, dev SDA is a disk, like an actual disk, like a hard drive. And raspi.image is an image of a disk. So this is the way that you take a disk and create an image file out of, well, here, I've got that backwards. Well, this is how, if you already have an image file, say you created that image a long time ago, and you want to copy this onto a disk, this is how you'll do it. It will use the parameters of however the image was created in the first place. But if you want to change any of that, you can decide how big the block size is going to be. 4 megabytes, 1 megabyte, 8 megabytes, however big you want that to be. And conversion is not necessary, not all the time. This was pulled straight out of a Raspberry Pi how-to. So this is the literal answer of, well, how do I move or how do I copy a Raspberry Pi image onto a disk, onto a flash card or something like that? That is literally how you do it. That is the answer to that question. So in some cases, you don't need all that information. In most cases, DD will work with just an input and an output. So I had mentioned before, if you wanted to take a backup of a disk, you could do that. Dev SDA, output file of temp SDA backup.image. So if I did this, a copy of SDA would eventually, after a little while, it takes a while to copy, end up with sda-backup.img. So that'll take an entire copy of that disk. All right. I've already done makedir before, but I'll do it again. Another example of a dir. So make dir, make directory, and I called it another example of a directory. And there it is. I'm able to get into it. I'm able to create files in it. Now here's the age-old question. How do you get back out? I don't know if you've noticed. I don't think I've done it, actually. Yeah. That shortcut thing? Yeah. That's how you go back. Back one. Just one directory. Yep. Because I'm in Home Leo, another example of a dir. And then to go back, now I'm just in Home Leo. So let me do that again, watch. See, this is what I'm talking about. You got to be careful. But I will show you. So to go back one, like that. And then we do pwd. So that's where I was. Going back one, oops, this is where I am now. Now, let's go back in there real quick. Let's go back two. If you want. Yep. Yep, just like that. So if we type that, pwd, right? So we were here, and then we got rid of this one, and we got rid of this one, and now we're at just home, right? That's how you go back 2. Now, don't get too knee deep into that just yet. Do one at a time, as many times as you need to do it. And then once you start understanding directory structures and how to move around, that it'll make more sense when you run things like that once you get a little more comfortable with it. Now, by all means, go right ahead. All right. So, all right. So we've got this. Let me make one more directory. I want to show you the difference between rmdir and rm. So, all right. So I've got another example of a dir, and I just created another one called testdir. Let's do rm testdir. Oh no, cannot remove testdir. It is a directory. So what do? Rmdir. So there's a command that is specifically meant to delete directories. Rmdir. And it'll work. And now it's gone. But here's the thing. Rmdir is very specific and particular about what kind of directories it deletes. So rmdir, let's do that one. It's not empty. So you're meant to go in and empty out the directory and then delete the directory. It's a safety catch, right? But that's really tedious and I'm lazy. So instead, what you want to do is the rm command, but you've got to give it a special option, R. So that R stands for recursive. If you've ever taken a programming class, you know what recursive is. If you don't know what recursive is, it basically means this and everything inside of it. Or loop it is the programmatic way to think about it. Loop it. RM everything inside of this and then the thing itself. That's how you get around this. Oh, rmdir can't remove it because it's not empty, and rm can't delete it because it's a directory, and blah blah blah. It's not empty. Yeah. But if you've got 7,464 files inside of this directory, may God have mercy on your soul, because you're going to have to tell it yes to every single one of those files. Unless you add the F option. The F option stands for force. Or it's just another way to say, don't ask me, just do it. Now, are you getting why this might not be the smartest command to run, like, ever, really? Because you're telling Linux, I know full well what I'm doing. Don't ask me any questions, just do it. And man, if you type the wrong thing in here. Do you remember when I did rmrf etc? And it deleted everything and didn't ask me a single thing about it? Yeah, those are the kinds of trouble. That's the kind of trouble that you can get yourself in if you're using rmrf. So, I can do that, though. And it'll delete this directory and everything inside of it. And it works. And it doesn't ask me anything. But don't expect any of those files to go to the trash bin, because remember, RM does not put anything in the trash. It just throws it away immediately, straight to the dumpster. No recycle bin whatsoever. Gone and gone. So one of the cool things that you can do with these commands, though, is you can double up or triple up or quadruple up or whatever. Just give it a whole list. So, Raspy, account.backup, account.text. All right, look at what this says. Remove that, but what's this? Will this work? All those files exist. Will it work? Yeah. It sure will. It'll take as many arguments as you give it. So you hit it. And now what? Nice and clean. The files that I told RM to deal with, it dealt with. No recycle bin. They're gone. So that's actually pretty decent as far as doing things as quickly as you can go. Otherwise, you would have to done rm raspi.image, rm account.backup, rm account.text, right? So instead of typing it 3 separate times, just type it once and name all the files that you want. Locate. I should have this backwards because update DB is required before you run locate. But this will, oh wait, oh, so locate's not here. Hey, so let me see, sudo, ooh, here's a question. How do you install software? What is the package manager called in OpenSUSE? Here's a hint, it's not apt. Zipper, yeah, and if I could type, it would work. Zipper, I don't know what it's actually called, so I'm just gonna guess. In Ubuntu, it's called mlocate. Just shooting in the dark here. We'll find out. I believe in you, OpenSUSE. Oh, sure enough. The following recommended. Cool. Are you cool? We're cool. We're cool. Mlocate. Yes. Did you notice? I mean, I was mumbling to myself, but did you notice I didn't just slap yes on that? You read the thing. Read the thing. I promise you, you won't regret reading it. It might be boring, but you won't regret it. All right, so now we can update DB. All right, so there's not a whole lot of files on this machine, so that doesn't take very long. But once you get to like thousands and thousands and thousands of files, update DB might take a little while. What update DB does is basically it indexes every single file on the entire system where it is. Everything. Every single thing. All the things. So that you can turn around and say, locate SDA. Well, that's kind of weird. Because what I wanted to find were the actual hard disks, right? Well, the hard disk and the partitions, there they are. Cool. They exist in dev. That's exactly where they are. Fantastic. What is this? Lib modules 412 blah, kernel blah, drivers net, erda, blah, 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 blah. You see that? It's got SDA in the name. So that makes it a little difficult. But locate's very, what's the word here? Literal. So it'll literally give you everything that has SDA in it. And then right, forms data, SDA. So it'll find everything. You can also do locate Firefox. But that's everything with Firefox in it. So that makes it very, very difficult to figure stuff out. So we'll come back to find here in just a little bit. But in cases where you're trying to find binaries, when you're trying to find like software to run, the which command is a little bit better. Bink, just one. So if you're gonna run Firefox, you could literally type user bin Firefox. That would work. But if which is finding it for you, that means it's part of your path. Right? User bin is in my path, and Firefox is in user bin. That means that I can just type in Firefox, hit enter, and it'll work. I don't want to do it because I don't have a lot of RAM on here, but that would launch Firefox. Yep, that would turn it on. Yeah, it will actually turn Firefox on, and you can use it. But this runs into that thing where you have to push it to the background, right? If you just run Firefox and Firefox runs, then if you close this terminal, Firefox goes away with it because Firefox is a child of the terminal. So you have to push it to the background and keep it running. In the last lab, y'all did some anding, did a little and whatchamajiggy. So that would be a better way to run it. Anyway, which is kind of important. Oh yeah, okay, so where is similar it'll find you the binary, the actual executable program. It'll also find you corresponding libraries. All those libraries exist in lib64 Firefox, or user lib64 Firefox. And the man pages exist in user share man1 Firefox.1.gz. So which is when you just want the binary. Where is when you want the binary and supporting files. And locate is when you don't care, you just want the word Firefox to be searched in the entire system. So there are tons of ways to figure things out where they are on the system, so you can get at them, delete them, move them, whatever you want to do. And those are a few of the ways to do it. Find is way more programmatic. So you can do things like this. You don't have to have the rest of this, but find netshare user Betty is basically looking in the directory called /netshare, and any file that Betty owns, that Betty is the user owner of, it'll display. Now, you can go further and actually execute something at the end of that. So a lot of times what people do with the find command is find files, and when you find those files, do something with them. So I found all of the files that Betty owns in the netshare directory, and I want to execute the change group to accounting. And then this is what closes off that essentially script. That's just something that you'll have to remember to put on the end of find whenever you're running execute, when you're running the execute option. But I know we haven't covered this, but this basically changes the group ownership to accounting. That way, accounting might be able to edit the files that Betty is the owner of. Because by default, well, in most distributions, because OpenSUSE is not one of those, any file that you create is owned by you and group owned by you. So this is a way to go make accounting the group owner of any file in netshare that Betty owns. So, yeah, I don't have anything set up right now. And it'll take a little while to set that up. But so I'm not going to test you on find. Let's just put it that way. Find is actually a lot more difficult than it may look. But we'll cover it some more later on, because there are times when you cannot get around having to use find. There are just some parameters that you need to use find for. All right. So we saw symbolic links earlier, right? I mean, you have this file that points to another thing. How do you create those? With the ln command. So ln will create a link. So let's say I wanted to link the bin directory into /tmp. So we can do a soft link. I always get this backwards. I'm pretty sure I always get this backwards. So link softly, just a shortcut, bin to temp. But I'm telling you, I always get this backwards, so let's see if this works. All right. Hey ho, it worked. Cool. All right. So, oh, wait a minute. Oh, it uses the full. I got it. Okay, so so I linked it. It actually worked, but because of where it is, it doesn't know where this is, and that's why it's colored like that. It's a broken link. Red and yellow, broken. So I've got to go in and remove that real quick. All right, so that should fix that. Right. And so the problem that I had up here is that I need the full file path there. Let's see if that fixed it. There we go. So it changed from, I'm sorry?
What if you didn't remove what you removed, but you corrected yourself anyway? What would happen?
Oh, if I didn't remove it, that would still be there. Yeah, it wouldn't have changed. It would just still be there. So now it looks like this after rerunning the command, but with the absolute file path. So we ran into the situation where you need an absolute file path. And that's what it'll do. So I can go into cd temp bin. Ooh, it actually puts me there. But it links to home Leo bin. So let's, all right, and then let's see what happens if I go to home Leo bin. Still there. So I was in TMP bin, created file 1, and then I moved to home Leo bin, and file 1's still there. So, linking, it works. So you can also do this as a hard link. So instead of one directory pointing to another or one file pointing to another, they are two separate files that share the same inode. So inode, you can think of inodes a lot like how blocks exist on a hard disk. It's pointing to the same spot on the hard disk. So that means that if you edit one, the other one also gets edited. So if you're hard linking one text file to another text file, it doesn't matter which one you edit, the other one will share that once you save it. It will share all those changes once you save it. When you delete one, that one goes away. The other one still exists. So the difference is, if I went in and deleted home Leo bin, this would now be broken. It would not point to anywhere. And you could not go into it or edit it at all. That's a soft link, right? That thing just points to another thing. A hard link is different in that if I went and deleted home Leo bin, temp bin would still exist, would still have all the files inside of it, and I can continue on my merry little way just the same as had I never deleted the hard link over here or whatever the hard link is pointing to. So a hard link is like a mirror. It creates a whole nother one. A soft link is just a pointer. You're not really looking at me, you're looking at that file over there, so go to that file over there. The difference really turns out to be when you're deleting one, the other one doesn't delete in a hard link, but does in a symbolic link. All right. Yes, a synchronized copy. That's a good idea. That's a good way to think of it. That's exactly what it is. A syncing copy. All right. So we're going to dive into some of this, and we'll finish the rest of this up on Thursday. So everything that I've been typing in, all these commands, moving this, copying that, linking this, deleting that, whatever, all of that has been input. You don't got to think about that too terribly hard, right? You're typing stuff in and submitting it as input to the terminal, right? That is standard input. That is its proper name in Linux. And it's given a designation of 0. That's not the important part. 1 and 2 are the important parts, as we'll see in just a minute. So, standard output is what the terminal says back to you, right? So if I do ls, that's standard input. Everything that came back, in this case file 1, is standard output. Now, if I typed in does not exist, right? /d&e, that folder does not actually exist. I'll get that. That's not what's inside of /dne. dne really doesn't actually exist. So it tells me cannot access dne, no such file or directory, right? So it's informing me that something didn't work. That is standard error. Operator error. Yeah, it's another good way to think about it. Right? Yeah. And you will. And, you know, it doesn't matter how good you get. You're going to typo something, and you're going to get this. Doesn't matter how good you are, how seasoned you are, how many years you've been dealing with Linux, you're going to mistype something, and it's going to break. So you will be getting that every now and then. The thing about these two is that sometimes you don't actually want it in the terminal itself. Sometimes you want this in a file. So let's go to home, and let's do that, right? Well, I don't want that to come out into my terminal. I want to save that for later. I want to save that into a file so that I can access it later and everything is good, right? I'll go look at this tomorrow. So I don't care what it is now. I'll look at it tomorrow. What you can do now, you can basically do this. That is the formal longhand way of saying this. You can redirect standard output like that. But the terminal assumes that you're always talking about standard output. So you don't actually have to put that one there. But that one corresponds to this. And then you can say ls output. Nothing comes out. That's what I wanted because this is a redirect. That is a redirect. Don't give it to the terminal. Give it to that file. And let's test it. File, ls output, what kind is it? ASCII text. It's a text file. It's got text in it. It's not empty. And then we can use cat to do ls output. And there it is. Without all the fancy colors, there it is. And that will never change. Unless I update it, of course. Now some funky stuff. You can do this over and over and over and over and over again. What do you think happened to that file? That's redirecting text into that file every single time. What do you think is happening to the file on the inside? You're right. It is writing over it. So if I cat ls output again, it's the same thing. The dates and times might be updated a little bit because sometimes those files change, but it's just overwriting it. Well, what happens if I want to just keep adding to it? I don't want it to overwrite over and over and over again. The fix for that is that. Double arrow. And that will add and add and add and add and add and add and add. Right? I did that on purpose because I wanted to run into a situation where I had more text than I could deal with. Right? And that happens and happens and happens. There's a lot of it. Right? So in a graphical terminal like this, except for in CentOS for some crazy reason, the scroll wheel will work and move you up and down this thing, right? Like it totally does work. Not in CentOS though, because CentOS is weird. But cat is not a good solution anymore, right? Especially in situations where you're in CentOS. You want to use the arrow keys to move up and down or page up and down to move up and down. You can do that with less. And now you can see, and it even tells you where you're at in the file, how many lines there are. You're at the end, 80%, 50%, 30%, whatever, right? You can move up and down, page up and down also work. And then Q will exit you out. So you can continue to look at that file back and forth, different spots, over and over and over again. All right. Well, what if you want to do just standard error? So let's do ls to, well, let's do an L. So basically what I'm saying is only redirect the errors. Did that work right? What's that? It did make a different file, but is having all that stuff come out to the screen correct?
If it wasn't correct, would it tell you?
In this case, I don't think it would. Well, if you mistyped something, it would. So what I'm saying with this is only redirect the errors. Everything else comes out to the screen. So that did work properly. The standard output is on the screen, and any errors that are generated went to the error output file. So let's look at... What does that mean? What's that? It's empty. So what does it being empty mean, though? There are no errors. Yeah, I redirected the errors. There were no errors. So everything worked right. So if I did... That'll break. Right? Well, I assume it will. Actually, I don't even know that it will. Oh, it won't. How about, let's do... There we go. That was an error. There you go. So it logged the errors. All right. So we'll play with these more. We'll add in standard output, standard input, and do a lot of fun things with that. But we're kind of running out of time, so I don't want to take it all the way. So instead, I'll leave you with the standard input, output, and error. And then on Thursday, we'll go through the rest of this stuff. The rest of this is going to go pretty quickly. So it probably shouldn't take us more than 30 minutes on Thursday to get this done. I know it seems like a lot, but it's really not. Most of this stuff is just symbolic. So anyhow, I'll leave you with that. I know y'all are just ready to get out of here, but I'll ask anyway. Any questions? Yes. What's that? Yeah, it might. It's getting cold. Just so I get this on recording, I don't know what's going to happen. If for some reason we do not convene on Thursday because of inclement weather conditions or something, then I don't know. We'll figure it out. If I have to, I may just record something at home or whatever and send it to y'all or whatever. I mean, it's a snow day. I can spare 30 minutes. Yeah. Right. I mean, in that case, we'll work with it. We'll figure it out. Yeah. All right. Any other questions? I'm sorry? We'll cover it on Thursday. I don't think there's... Well, yeah, okay, actually. Yeah, I got a couple minutes. I'll go ahead and do it. It is quite literally just follow the instructions. So one of the things that I have had come back a few times is this one-line command. What I mean by this is I want you to write one single command that does the thing I'm asking. So I want to find the location of 3 different commands or binaries: yum, parted, and tar. So those will all exist in your CentOS VM. And then I want to see the command and the output. So basically, you're going to ask Linux, show me where these 3 things are. And you're going to do it all in one command. And then it's going to give you 3 separate answers. So 1 command, 3 answers. That's what I'm looking at here. And then this one here, same kind of deal. In Ubuntu, create a one-line command that both updates the apt cache and upgrades all packages on the system. Y'all have already done this before. You just didn't do it in a one-liner. So reach back 2 weeks ago, figure out what that is, and then it's going to be in the notes. We hadn't covered it yet. Maybe it's on the screen at this moment. I don't know. Could very well have been. So if you watched this far into the video, congratulations, you get 1 freebie. And then copy. So this is another one. Copy this poem. I had a lot of people ask me about this. The poem is literally just text on a web page. So open up Firefox in your VM and copy the text into a file of some kind, and then start to work with the file. You don't have to do any kind of weird terminal magic to make all that work. Literally open up a text thing, copy the file into it, and then you're dealing with it. I don't have a screenshot for that one, so I don't care how you get the text, just get the text. If you want to type it all out, you can, but don't. So anyway, but at this point, it's really just follow the instructions. So create a home folder named important in the CentOS VM. Inside that directory, create 3 files, name them that. Put them into a gzipped archive, and then display the contents of the archive without actually extracting the thing. So we didn't cover archiving yet either. That's going to be on Thursday as well. We did cover moving though. So move that archive to temp. Remove that whole directory that you started with. And then, figure out what type of file the gzipped archive is. I know you know, because you obviously created it, but have the terminal tell you the answer. And then, so we talked about the poem, whatever. One line command that cuts and displays the first letter from each line of the poem. So you're just doing text manipulation. We didn't cover that command today either. So again, Thursday. But basically what I'm doing is there's a bunch of lines in that poem. I want you to just extract the first one. So it'll be like C, and then F, and then D, and then whatever, right? Just the very first line. And then I want you to search that whole thing for the word and have it show you only the lines with the word and in it. There'll be a few. And then run dmessage, but only display the last 12 lines of that log. So a lot of these commands we just didn't go over yet. So don't freak out. Don't freak out. We're getting there. I promise each of those will take, okay, well, the gzipping part will take you a little while of head scratching. But the actual file manipulations, 1 and 3, 4, and 5 on these, shouldn't take but 10 minutes. And then same with that one. Y'all have already done it. And then, this one might take, this is the one that's going to take a little while. But these two will be pretty quick. So I don't expect more than an hour on that lab. But then again, yeah, we're getting there. We're getting there. So that one's important. Let me see. Cut is important. Wherever that went. Yeah, cut. And there's a few. Tail is important. All to that lab. See, if you watch to the very end of the video. Hints, man. Hints. All right. So we'll cover that. And with those hints, I mean, to be honest, with those hints, you could probably get the lab done. But, you know, you got to actually have been awake right now or watch to the end of the video after I posted it. See, you got to watch the whole thing.